Greetings of the day. Welcome to R.M.K. CET. I am Pratima, currently dealing the course Signals and Systems. In this video lecture, I am going to explain concepts under discrete time Fourier transform. First of all, before going to explain Dtft, I would like to tell why Dtft. Actually, these transformations will be used to transfer the signals from time domain into frequency domain. Why we need to transfer time domain signal into frequency domain means first purpose is analysis purpose. In time domain it is difficult to analyze a complex signal, so we will go for spectrum. It's spectrum for analyzing purpose. So for continuous time signals we will have Fourier series, Fourier transform and Laplace transform. So similarly here also for discrete time case we will have discrete time Fourier transform and Z transform. In next video we will see Z transform. And why discrete time Fourier transform means, to analyze the discrete time signal we will use discrete time Fourier transform. It is applied only for discrete time sequence. So now with this understanding, what is Dtft we will see. So how it is represented means, for a sequence x of n, it is given as x of omega, and this is the formula summation over minus infinity to infinity x of n e power minus j omega n is the formula, and this integration will gives you inverse Dtft formula. Since its Fourier transform, discrete time Fourier transform is continuous in domain, so it will takes integration in inverse transformation, and this is representing Fourier transform pair. So next, existence of Dtft. Likewise for for Fourier transform and Laplace transform existence, we are having existence of Fourier transform. Likewise for Dtft also we are having existence of Dtft. So if the given signal is absolutely summable, then only it will have Dtft. So mathematically how we can represent means, summation over minus infinity to infinity modulus of x of n will take finite value. It should not tends to infinity. Then only the signal will have its transformation, otherwise it won't have Dtft. So for first problem we will see for del of n. So what is the formula first? For x of Fourier transform of x of n, which is represented as x of omega, this is the formula summation from minus infinity to infinity x of n e power minus j omega n. So here the signal is del of n, impulse. Impulse is nothing but, for n is equal to 0 it will become 1, for n not is equal to 0 it will become 0. So for this, if we evaluate this summation for impulse, so it will be exist only for n is equal to 0. So put n is equal to 0 here, e power 0, anything power 0 will become 1. So Dtft of impulse is 1. Likewise we will find out Dtft for step function and so on. So what is u of n step function? It will be 1 for n greater than or equal to 0, positive values of n. For negative values of n it is 0, since it is a causal signal. So this is the formula. So what we need to put, the limits will change from n is equal to 0 to infinity. Wherever you find a signal multiplied with u of n, then automatically the limits will change from 0 to infinity. So amplitude is 1, so e power minus j omega n as it is. So expand this one, and it is in the form of summation n is equal to 0 to infinity a power n 1. So for this, what is the formula means, 1 by 1 minus a, where a must be a rational number. So for this 1 by 1 minus a, in the in place of a we are having e power j omega. So here it should be e power minus j omega minus 2j omega. If you expand this, you will get here minus. Note it down. So 1 by 1 minus e power minus j omega. So now what is the relationship between Z transform and Dtft means, if we put e power j omega as z, then it will become Z transform. So next sum for this finite sequence. So what is the discrete time Fourier transform? So in this summation we will have formula for Dtft. In this summation we are going to substitute limits from 0 to 5. So amplitude is 1. So for finite sequence this is the formula. We must apply a power n for finite sequence. It is not infinity. So for this type of sequence series, for this type of finite series we will use this formula. So according to this formula it will become 1 minus e power minus j omega 6 by 1 minus e power minus j omega. This is for finite sequence. Next, shifted version of u of n minus 2. You can simply write using property, time shifting property of Dtft. Otherwise you can use this formula and calculate. This is the u of n minus 2. So it is shifted to right hand side by 2 units. So n greater than or equal to 2, it will become 1. This n values we will substitute in limits. So from 2 to infinity. So we will substitute expand summation and e power minus j 2 omega get common. So we will have this infinite series. So infinite series, for infinite series 1 by 1 minus a is the formula. So 1 by 1 minus in the form of a, we are having e power minus j omega, and e power minus 2 j omega is common. It is already outside. So it, as it is, we are writing e power minus 2 j omega. So this is time shifting property also. From the time shifting property also you can write directly. In next video you will see time properties of Dtft. So this is next problem. This is also finite sum, but it is given like a sequence. So there is no arrow mark. So n ranges from 0, 1, 2, 3. So n ranges from 0 to 3. For x of 0 the value is 1. For x of 1 the value is minus 2. For x of 2 value is 2. X of 3 value is 3. So you can expand like this and you can stop here. This is the Dtft of a finite sequence given like this. Next, discrete time Fourier transform for a power modulus of n. So how we can write modulus of n? Modulus of n will take negative values for n less than 0, and it will take positive values for n greater than 0. So split summation like this, minus infinity to 1, 0 to infinity. In continuous time we will have integration from minus infinity to 0 plus 0 to infinity. But in summation 0 won't be repeated. One time only you will have 0 value. So here minus infinity to minus 1 you will have. So reverse the summation. So sign of n also reversed. So it is it can be written in the form of a power n. So that expand this one. If it is start from n is equal to 0 to infinity, then 1 by 1 minus a is the formula. For that add and subtract a e power j omega whole power 0. So here also it is added, here it is subtracted. So same we will get. So simplify this equation and write it is in the form of 1 by 1 minus a square by 1 minus 2a cos omega by a square plus a square. So this formula, this problem is very important, frequently asked for either Dtft or for Z transform. If it is asked for Z transform, in place of e power j omega, substitute Z. So I hope you have understand something about Dtft, why Dtft, what is Dtft, and how we can solve for different problems. For function, if it is given to calculate for function, how to proceed. If it is given to find out for finite sequence how to find out, infinite sequence how to find out. Thank you all.